Experts believed it was impossible. No one could do it. 120 botched attempts, 1 miscarriage, 1 death, but 1 survival. Meet Snuppy, a resident dog at Seoul National University. The 3-year-old male Afghan hound is a bundle of joy for the scientists at the College of Veterinary Medicine, for he is no ordinary dog. He's the world's first cloned dog. A human body has 10 trillion cells. Each cell contains 22 pairs of chromosomes with a pair of X and Y chromosomes that differentiate our gender. Within these tiny chromosomes are DNA coils unique to the individual. For our body to function, there are 35,000 genes strung out in a definite order within the DNA coils. These genes each carry a specific chemical message that instructs the cell to make different proteins to maintain the human body. Now imagine if we could manipulate the chemical message each gene carries. What breakthroughs in the field of genetics and cloning could we achieve? Could we even tailor-make our genes? Cloning is the creation of an organism that is an exact genetic copy of another. There are several cloning techniques, such as artificial embryo twinning and somatic cell nuclear transfer. In the past, scientists cloned using the artificial embryo twinning technique. This is the technique that most commonly comes to mind when one thinks of cloning. Here, an embryo in its early stage is manually separated into individual cells and placed inside Petri dishes. The cells develop on their own, resulting in 2 similar embryos which are placed inside a surrogate parent, carried to term and delivered. But a more sophisticated method yielding better results today is the somatic cell nuclear transfer technique. It was first used to develop Dolly, the world's first cloned sheep. And now this progressive technology has been used to clone the hardest animal to date, a dog. It took them several years of trial and error, but Seoul finally made headlines when it took the world by storm in a series of successful dog cloning procedures. It all happened on the campus of Seoul National University. Snuppy, a male Afghan hound, was born on the 24th of April 2005. Named after a combination of Seoul National University and puppy, Snuppy has captured the attention of scientists and dog lovers around the world.
I remember in 2003, I went to Chicago Medical School. Then I visited Science and Industrial Museum in Chicago. I found one panel. They described what is cloning, and I pushed one button, but they say, cat already cloned by scientists, but dog is not yet cloned. I decided I should clone the dog, and I can change this panel.
So how did Professor Lee's determination become a reality? It all lies in a method known as the somatic cell nuclear transfer. A somatic cell is a body cell other than a reproductive cell, like cells of internal organs, bones, and connective tissue. Within the somatic cell is the nucleus, which contains all the DNA information. In the creation of Snuppy, Professor Lee and his team used a somatic cell taken from the ear of Tai, Snuppy's genetic donor. The nucleus inside Ty's somatic cell is removed and must later be inserted into an empty donor female reproductive cell, also referred to as an oocyte. Then there is the task of selecting a good oocyte. First, they need to be extracted from ovaries in a process known as aspiration. Once the oocytes are aspirated, researchers begin a painstaking process of carefully selecting the better qualified oocytes to be used in vitro maturation. In vitro maturation, the oocytes are matured in the laboratory to be used in the somatic cell nuclear transfer technique. The nucleus from a donor egg cell is removed. Ty's somatic cell nucleus is then inserted into the empty oocyte and undergoes electric fusion. Finally, the embryo is implanted into Snuppy's surrogate mother, a golden Labrador retriever, and then carried to full term. The South Korean team may have achieved the impossible, but it was a long and difficult journey, one that involved 3 pregnancies, 1 miscarriage, and 1 death. After the break, discover the difficulties the team faced as they attempted to realize the somatic cell nuclear transfer technique in cloning a dog, and uncover what it means to be a clone. Just how similar are Ty and Snuppy in terms of looks and character. The quest for cures for human diseases has perhaps found its answer in the technique behind dog cloning in Seoul. In 2004, Snuppy, the world's first cloned dog, was born. It was a triumphant yet arduous task for the team at Seoul National University, who spent over 2 years attempting the feat.
When you're starting dog cloning, we have no information about dog cloning. We approach it trial and error. We tried more than 100 times the somatic cell nuclear transfer procedure. We transferred to 123 surrogate mother. Among them, we got 2 puppies. Now the Snuppy is alive.
One of the challenges of cloning a dog is understanding a dog's physiology.
Dog is a very unique animal, especially reproductive physiology is very different from other animals.
It's precisely the unique physiology of a dog that raised many obstacles for the team cloning Snuppy. The first is that a female dog only comes in heat once or twice a year, making the number of eggs that can be harvested limited. Adding to that problem, only good quality eggs must be selected from the small amount of harvested eggs. This would hardly be enough to meet the needs of the team. Making matters worse, the harvested eggs from the canine ovaries were not matured enough to be coaxed into pregnancy. They couldn't be used. The frustrated team tried several methods to mature eggs under a laboratory environment, but failed. They then came up with the idea of allowing the eggs to mature inside the ovaries before harvesting them. But this posed another problem.
The maturing stage is very short, and several hours after the maturing, they easily aging. We should select very limited time for the good quality oocyte. That is very difficult.
Besides a time restraint, there was the problem of harvesting the eggs. By the time the eggs had reached maturity, they had migrated to the oviduct, a thin tube that carries them to the dog uterus. Locating the eggs in the oviduct was a painstaking process. Harvesting them required extreme accuracy. After years of practice, it was a great victory for the team when they successfully harvested the eggs. There was even talk of the chopstick theory of scientific supremacy. Koreans eat rice with narrow metal chopsticks. That's why Koreans have mastered extraordinary precision and dexterity, and may explain their fantastic micro-manipulation of eggs and embryos in laboratories. Professor Lee and his team may have cloned a genetically identical dog, but just how similar in looks and behavior is Snuppy from his donor?
Some characteristics came from the genetic background. For example, Thai wants to walk one side when they walk the pair, the same to Snuppy. When Thai meets somebody, he smells fore and back. Snuppy exactly the same, that characteristic. Also, Thai suffer from ear inflammation problem, and also Snuppy has the same problem.
While cloning reveals some surprising results, the primary biomedical benefits of cloning stem more from the use of this technology than from making identical copies.
The purpose of research is to producing human disease model dog and developing some drug for human disease. Dog has the same disease to human, around 223 kind of human disease. That means dog is the most useful and good for human disease model animal.
With the successful cloning of Snuppy, South Korean scientists now have a better understanding of the genetic makeup of canines. If they can apply this knowledge for dogs, therapeutic cell therapy for humans may one day be developed. Many diseases could be treated by the transplantation of genetically altered cells. For example, Parkinson's and Alzheimer's are caused by the death of specific cells in the brain. Preliminary research has shown that it's possible to alleviate the symptoms of Parkinson's by transplanting fetal pig brain cells into a patient's brain. Another application of the cloning technique is genetically modifying animals to disguise their cells and organs so they can be transplanted into humans. Transplantation therapy could most certainly relieve much suffering for patients. The potential benefits of cloning technology in curing human diseases are limitless. And perhaps the most interesting endeavour to date is the cloning of 4 Labrador retrievers, cloned because of their ability to detect cancer in humans. The South Koreans are proving themselves to be masters at cloning. The team at Seoul National University has cloned more than 30 types of dogs without any abnormality. The most recent to date, the world's first cloned cancer-sniffing dogs. The project is a tie-up with RNL Bio, a premier biotechnology company that focuses on life sciences technology and therapeutic cell research. They're also the company that kick-started the world's first commercial dog cloning. The world was set abuzz on the 5th of August 2008 when news broke that the world's first commercial pet dogs were cloned. Vernon McKinney, a physically disabled woman from the United States, wanted to clone her beloved dead bulldog Booger, who had once saved her life. Using frozen cells taken from the dead dog's tissue, the team successfully cloned 5 Booger Juniors months ahead of the schedule set in February 2009.
이제 최근에 그 부고 복제 소식이 전 세계로 나가고 나서부터 미국에서도 그 의뢰가 되고
In fact, RNL Bio has clients from Korea, Russia and several countries in Asia. They're currently reserving the somatic cells of each of their clients' pets for cloning. R&L Bio is currently charging $150,000 for the cloning of each dog. The high price is due to limited manpower and current high operating costs. But as research continues and productivity increases, R&L Bio hopes to lower costs within 3 years. They hope to charge around $50,000 per dog. But pet cloning isn't the mainstay of R&L Bio. Their focus, dogs with jobs. Their latest endeavour is the cloning of 4 cancer-sniffing canines. Marine, a black Labrador retriever from Japan, is touted as having a world-class cancer-sniffing ability. However, she lost her ability to reproduce when she had her womb removed because of disease. R&L Bio and the team at Seoul National University couldn't let such good genes go to waste.
암을 조기 진단하는 방법이 여러 암에 대해서 지금 개발되고 있지 않습니까? 그런데 아쉽게도 폐암 또는 췌장암, 유방암 이런 암의 경우에 조기 진단이 어렵거든요.
Using cancer-sniffing dogs, however, could help in early detection. Apparently, cancer cells that circulate in the body and blood emit a certain smell. This scent can't be detected by us humans, but dogs have a heightened olfactory system that can pick up this scent.
I went to Japan with the R&L Bio scientist, and the Japanese trainer showing us how can detect the cancer. They collect the breath from normal person and cancer patient, and they hide that breath bag several bags. And the Marine, the name of the cancer sniffing dog, she easily found the cancer patient breath.
Marine's trainer in Japan requested that she be cloned. Marine's skin samples were sent to Seoul National University, and after undergoing the somatic cell nuclear transfer technique, the team implanted the cloned fetuses into a surrogate mother, and she carried to full term. R&L Bio says the 4 retrievers will be sent to Japan after 3 months to join the training program for cancer detection. Each cloned dog will be priced at $480,000.
암 탐지 능력이 있는 아주 우수한 마린을 내년에는 한 20마리 정도 더 국제화리가 보여서 얘들을 훈련을 시켜갖고 우리 여성들의 유방암을 조기에 진단하는 그러한 서비스 사업을 저희가 내년 하반기부터 시작하려고 합니다. 그래서 이렇게 함으로써 더 많은 우리 전 세계 여성들이 유방암을 조기에 진단하는데 이 복제 기술이 도움이 될 거라고 생각합니다.
And that's not all R&L Bio is up to. Research is currently underway to uncover how it is these cancer-sniffing dogs are able to detect cancer using just their sense of smell. R&L Bio hopes to uncover the kinds of scents that cancer emits. If they can pinpoint the different smells that the various types of cancers give out, they can develop a diagnosis kit which can help in early detection. The technology of cloning has brought about many possibilities besides medical and scientific purposes. R&L Bio is also looking to clone wolves, which are in danger of extinction. Their immediate future goal, though, is to clone another animal that hasn't been cloned before.
저희 회사 갖고 있는 계획 중에 하나는 첫 번째는 낙타를 복제 연구할 계획을 갖고 있습니다. 낙타가 카멜이 그런 운송 수단으로만 쓰이는 게 아니라 이제는 그런 경주용으로도 쓰이고 있고 애완용으로 쓰이면서 아주 고가의 낙타가 있어요. 그래서 하나는 그런 고가의 낙타를 복제하고자 하는 수요가 있을 거로 예상이 돼서 그 사업적인 이유가 한 가지가 있고 사업적인 이유가 있고
Because no organization in the world has succeeded yet in cloning camels, RNL Bio also hopes to contribute to research once they've successfully cloned this animal. It looks like South Korea is set to remain in its position for a long time. The support from the South Korean government has boosted the country's biotechnology industry. Analysis from Frost & Sullivan on South Korean biotech markets reveals that revenues in the industry totaled $1.3 million in 2002. By 2010, revenues are projected to reach $6.3 million. When it comes to cloning, South Korea has proved it's setting global frontiers. The country cloned the world's first dog, one of the hardest animals to be cloned to date. It also has a strong and clear vision, cloning cancer-sniffing dogs and ensuring their legacy doesn't die out. And it seems like it has a knack for entrepreneurship as well, by starting the world's first commercial dog cloning business. When it comes to cloning and its technology, there is much to look forward to as Korea continues to surprise the world with its progressive work.